Here we asked you to play around with the diagram by dragging the points that were highlighted. And there's two questions that we want to answer. One talking about why we think the green inscribed angles are always congruent to each other. So we can see the measurements here for the angles. And then what happens if we move those inscribed angles into the interior of the black angle? Well, here's the black angle, 87 degrees. This is a central angle because the vertex is at the center of our circle. We know that the intercepted arc for central angles have the same measurement. So if this is 87 degrees here, the arc measurement should also be 87 degrees. Now we said that the green angles are inscribed angles because the vertices are along the circumference of the circle. So as we learned before, the inscribed angles should be half the measurement of their intercepted arc. So if I highlighted one of these angles here, right, this is the intercepted arc, it's half that measurement. Now some of you may be thinking, well, 43 isn't half of 87. Technically it should be 43.5. Yes, you're right. It just doesn't show up in our diagram here because they're so close together. Now let's think about this. We've got multiple inscribed angles and we want to see what happens. So let's go through and see what happens as we look at each of those angles individually. Do you notice a pattern? All of the inscribed angles had the same intercepted arc. Well, if they all have the same intercepted arc, and the relationship is the angle is half the measurement of the arc, they all should end up with the same measurement. So again, why are they congruent? They have the same intercepted arc, so they have to have the same measurement. Now our next question was, what happens if we moved the inscribed angles to the interior of the black angle? So again, instead of having the vertices here, what if they're on the interior of your black angle, that central angle? So let's take a look at a couple examples. If I moved where the vertex was, for example here, or here, or here, did you notice a pattern? Hopefully you're seeing that the same situation is happening here as it was before. They share the same intercepted arc. Well, if they share the same intercepted arc, then they'd have to be congruent to each other. Now, could we figure out the measurements of those new inscribed angles? Of course we can, because we know that there's 360 degrees for the arcs of our circle. So the circumference here has a measurement of 360 degrees. If we already know that this arc is 87, we could subtract that from 360 to find the other arc here, which would be for our new intercepted angles in orange. Well, these are inscribed angles, and we know they should be half their intercepted arc measurement, so we can find theirs as well. So let's think about this. 360 minus 87, that would be 273. Divide that by 2, you'd have 136.5 degrees. That would be the measurements for any of the inscribed angles that would fall along this portion of your circle.